Right, so history review. Over on this side. My computer over there wasn't working. My computer wasn't working, so I had to come over here. All right, so this one wants me to describe in behavior. So I got P of X is going to equal negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 1. Now, I'm going to make the in behavior chart again for y'all because it's been a while since we did that. So the in behavior chart looked at the degree and the lead coefficient. So your degree could be positive, how about even or odd? And the lead coefficients could be positive or negative. So this gave me 4 different outcomes. So if it's an even degree, positive lead coefficient, both ends shoot up towards infinity. And if you made that lead coefficient negative, it took that graph and flipped it so that both ends would be headed towards negative infinity. And then the odds were the ones that sort of went uphill left to right. So if your odd degree lead coefficient is positive, you're going to go uphill left to right. And then the only other case was if it was negative, it's going to flip that and make it go downhill left to right. Now the reason they leave all the gaps in the middle is because this is what's happening to the graphs as they go towards infinity. But depending on the degree, they might have a lot of terms in there. But in the big picture, they're going to have this shape, okay? So what I'm looking on this is my degree is even. So I got an even degree. My lead coefficient would be the negative pi, so it's negative. So the lead is negative. So even degree, negative lead coefficient. The only picture is the both sides headed down. And I'll tell you the truth, I use that chart on probably most of these that tell me to graph it, because that gives you the basic picture of what the graph is going to look like in the big picture. Okay? So I'll leave that up here for number 2, because it's the same problem in behavior. But this time I got f of x will equal negative 4.5 x to the 4th plus x to the 6th plus 0.1 x to the 7th. So the trick on that one is it's definitely out of order. So on this one, my degree would be the 7. So that is definitely odd. The lead coefficient, well, that's going to be the 0.1, and that's positive. So the lead coefficient is positive. So when you got a odd degree, lead coefficient is positive, it's going to be uphill left to right. And so that's the main thing you wanted to do on those first 2 is just have that little chart handy. And remember, if it's out of order, you got to pick the one with that highest exponent on it. Okay, so number 3, we started finding zeros. So 3 wants me to find the zeros and multiplicity. So to find zeros and multiplicity. So we're given f of x equals x squared minus 25 to the 5th power. Now here's the thing on this. The multiplicity is going to be them exponents on the outside of these parentheses. So the multiplicity is actually going to be the 5. Because that's how many times you would write those parentheses if you were going to FOIL this or do any fun thing like that. But to find the actual zeros, we need to take this x squared minus 25 and set it equal to 0. So, I'll knock this out by factoring real quick, but y'all can hit that with the quad, make the b 0. You can hit it with square roots. And so y'all like square roots? Well, hell, let's do square roots then. That's the easiest thing to do this is add 25 to both sides. So that you get x squared is what, a 25? And then take square roots. A lot of people can take square roots easier than they can factor. So just remember, when you take square root of this number, you got to put your plus or minus in there. So that this will give me x is what, a plus or minus 5. So the zeros, now MATLAB actually lets you write them both because it gives you A, B, C, D answers. So on there it would be plus or minus 5, each with a multiplicity of 5. Boy, these long words, multiplicity. So, you know, this is the main thing on those. The factors are all going to give you the zeros, and those exponents on the outside is always going to give you the multiplicities, okay? So knowing that, here comes number 4. Same thing, zeros and multiplicity. All right, now I got f of x is going to equal a negative 5 times x minus 3 squared, x plus 5 to the 4th, and then an x to the 3rd. So if you notice that, I have 4 factors sitting there. I got that negative 5, then the 2 parentheses, and then that x to the 3rd at the end. All these exponents are going to be the multiplicities. And one of those factors I don't even care about because it don't have a variable. And that's that negative 5. We ain't worried about the negative 5 because it don't have a variable on it. But we are worried about the other 3. So what you would do is take each of the factors and set them equal to 0. And then you're going to solve those. And the only 2 I really got to work with are the 2 that was in the parentheses. So if I add 3 to the first one, I get me a 3. And then I'll subtract 5 from the second one. So here's how they have this answer. The 0, 3 has multiplicity blank. Blank is a 0 of multiplicity 4. And then the remaining 0 is blank. It has multiplicity blank. So the 0, 3 has a multiplicity of 2. There you go, because that's the exponent that came out of the factor where she got that answer. Blank is a 0 of multiplicity 4.
Negative 5?
because that came out of the factor that had the 4 sitting there. And then the remaining 0 is
0, which has multiplicity of 3.
and that's it. So if you didn't get that right when you're solving it, you'd be out of place when you started trying to do these answers in there, okay? All right, the next one is the same thing, but it is a 4-term polynomial. So I'm still going to find zeros and multiplicity. All right, so y'all, here's a 4-term polynomial. F of x is going to equal x to the 3rd minus 8x squared minus an x plus an 8. So when you got a 4-term polynomial, the easiest way to factor those is what we call factor by grouping. So what you want to do is group the first 2 terms together and the last 2 terms together. And what we're going to do is factor out GCFs from each of those. So factor out GCF and factor out GCF on that one. So the first 2 terms, you got an x to the 3rd and a negative 8x squared. The largest factors they got in common, x squared. There you go. So you're going to put the x squared, and in the parentheses, you put what you get when you divide everybody by the x squared. Well, the x to the 3rd divided by x squared is going to leave you an x. And then if you take the 8x squared divided by the x squared, all that's left is the 8. Now, here's the thing on factor by grouping. We got to do that to the second group now. But the second group, their GCF always has to include the sign. So, I'll tell you a trick. The sign of the second GCF is always the sign of the 3rd term. So since my 3rd term is negative, my GCF will be a negative something. So, hell, what's an x and an 8 got together? A 1, and that's the only thing. So if you divide a negative x by negative 1, that's going to make it positive. And if you take a positive 8 and divide by negative 1, that's going to make it negative. But y'all notice, at that point, those parentheses better match up. They both better have the same thing in them, because that's the part that's going to help me finish this. They now have a greatest common factor, right? Both of these have an x minus 8 in them. So we're going to factor out that greatest common factor they both had. So if I factored out the x minus 8, what's going in the second parentheses?
X squared minus 1.
X squared minus 1. One of those can go further.
The x squared minus 1.
X squared minus 1. So I'm going to bring down to x minus 8. X squared minus 1 is perfect squares. Now, that's the smallest perfect squares you'll ever get. So in the front, you put the square root of x squared, you get an x and an x. In the back is going to be the square root of that 1, which is 1. So we got our 3 factors. Now set everybody equal to 0 and get those answers. Well, y'all, once you've seen enough of these, you're going to know all the answers are just opposite signs and what's inside them parentheses. Like a positive 8, negative 1, and then what, a positive 1 at the end? So I now have all my zeros. What's their multiplicities? 1, because remember, here's all the factors, and since there's no exponents, we treat it like a 1 by everybody. So all have multiplicity 1. Well, y'all sure did get better on these questions on these reviews than y'all did the first time I actually hit y'all with this, huh? So y'all got questions on those first 5? Main thing is just remember the multiplicities are the exponents outside of those parentheses.
Okay, I do have a question. So if we would have left it x squared minus 1, would there have been a multiplicity? Or does it have to be outside of the parentheses?
Well, technically there would be a 1 here also. So every parenthesis going through here, if it ain't got an exponent, it's definitely a 1 by it. And the only thing making me go further on this was because the x squared, I knew it had 2 answers in it eventually. So once you're to this point though, and you got all your factors, if there's no repeats, everybody's going to have a 1 by it, okay? All right, you're going to tell me if this is true or false. If p of x equals x minus 8 to the 4th times x plus 6 to the 9th, then the graph crosses at the point 8, 0. So this went back, so let me show you. If the degree is even, and then you got a choice where the degree is odd. If the degree is even, that graph is going to come down, touch the x-axis, and then shoot back up. It's going to be tangent to the x-axis. So if it's even, it's tangent to the x. But if it's odd, it's going to shoot right on through there. So odds will cross the x-axis. Which means, if it's going to cross at 8, 0, it had to come from the factor x minus 8 to the 4th. But 4's even.
So it doesn't cross.
So it does not cross, which means this is definitely going to be false. Now, this one, the x plus 6 to the 9th, that would cross at negative 6 and keep on crossing through it, right? Because that's an odd exponent.
So the one that's even would be the would be the one you go off on that one.
So if I was to draw this over here at 8, this graph, either from the bottom or the top, it just want to sort of touch it.
Yeah.
But over here at this negative 6, this part would probably come down and shoot back through there. Now, this could cross a lot of times because that's a lot of exponents in there. But they just wanted you to figure out, hey, that's even, so it's only going to be tangent, or hey, that's odd, it's going to cross on through there, okay? All right, so on this one, they're giving us f of x is going to equal negative 6x minus x to the 7. First thing they want to know is the maximum zeros you can have. Then the maximum x-intercepts you can have. Then the maximum turning points. Now remember, it ain't got to have this many zeros, but this is going to be the maximum amount of zeros it could have. Now, y'all have been through some of them 8.4 questions, and we learned in there definitely that the highest exponent or the degree is telling me how many zeros I can get at the most, right? So since that's a degree 7, the maximum number of zeros I can have is definitely going to be 7. So what do y'all think the maximum number of intercepts I can have? 7, because ain't the zeros and the intercepts the same thing, right? So the only one that's going to be different, how many turns are maximum? And you figure that out, you take that degree 7, and you subtract 1 from it. So the maximum turning points is going to be 6. But that makes sense. If it's going to hit the x-axis 7 times, it turns once, there's twice, turns again. So every time it's turning, it's hitting it, but since it takes 1 turn to do 2 points.
Yeah.
So 0 is when it's an x value, but the y value is 0.
Mm-hmm. Anything on that x-axis has a y value of 0.
So that's a 0.
Mm-hmm. And then that's why we hit you with these problems, so that y'all realize that those x-intercepts are those solutions and zeros. So zeros, solutions, intercepts, they're all the same. We just use different terminology in here. All right, so number 8 sort of goes back to the first 2 questions where I'm using the chart to get my picture. But they're doing it in factored form, okay? So we just want to choose the graph. So this one has h of x equals x times x minus 1 times x plus 1 times x minus 4. So when it's all factored, I need to find the degree of this so I know what pictures it's going to have. So to find the degree, you're going to multiply all the x's together. So you got how many x's there? 1, 2, 3, 4 x's. So if you multiply all them x's together, that would give me a x to the 4, which is definitely even. So then I would figure out, well, what's the sign of my lead coefficient? Well, what numbers are in front of all my x's? And 1 times 1 times 1 times 1 is 1. So the lead coefficient is going to equal 1. So you got an even degree and a positive lead coefficient. So in the big picture, both ends are going to head towards positive infinity. And if you'll note, all the graphs just have one that's both going up. One's going uphill left to right, one's going downhill, and then one they flipped over. But I do know this. All these x's have what, a 1 by them? Which are odd, which means all these cross through those values. It's going to cross through the 1, it's going to cross through a -1, and it's going to cross through the 4. Okay? And then this is even going to cross right through that 0, ain't it? So all 4 of those it's going to cross through. So it's not going to come down and touch it and turn. Okay?
So how did you figure out that the lead coefficient is 1?
Oh, because remember, all these x's have a
1 beside them?
1 beside them.
Okay.
And to get your lead term, you're taking all the variables to multiply. Okay?
Okay. So that happens when all the variables are equal to each other?
Mm-hmm.
Okay.
All right, let's see what you do to number 9. It's sort of the same stuff. Choose the graph. So f of x on this one will be 12x to the 3rd minus 9x squared minus 48x plus 36. So it's going to be one of my shapes. It's an odd degree this time. So an odd degree is going to go uphill or downhill. But that's a positive lead coefficient, which means this graph will go uphill left to right. Now, what you gotta look for, sometimes they'll put two pictures with the same thing on it. So I would look for, I probably would just shoot that on my calculator real quick. I'll tell you the differences on them is gonna be these y-intercepts. That 36 means it's got to cross that y-axis at 0, 36, okay? So one of them have a positive y-intercept and one kicks it negative. So just look at that real quick and that'll get you going on that, okay? Actually, I'll show y'all the pictures for that one. So notice that is y-intercept is 0, and then that's kicking up about, looks like 36 on it. So you gotta sort of, if they got two the same, sort of look at them y-intercepts on them, okay? That's what that was doing. So that looked like it went right through the 0, and then that one sort of kicked up a little bit. Looks like it could be the 36. So this sort of, if you got two that are both going the same direction, look at that y-intercept, and that'll get y'all through them, okay? All right, y'all, 10. They're going to give me 1 0. I'm going to find the remaining zeros. So, no, we're doing, my bad, this is a different one. So we're going to determine if the given numbers are zeros. So we're given -2 and 2 are the numbers they want me to check. And my function is going to be h of x equals x to the 4th plus 3x to the 3rd plus 2x squared minus 6x minus 12. So I'm going to check each of these one by one, and I'm going to use synthetic division. And if it's going to be a 0, my remainder better be 0. Okay? So I'm going to check the -2 first. Now my coefficients, all my places are here, so I'm just going to write my numbers. 1, 3, 2, -6, -12. Then, hopefully y'all like this synthetic division now. Bring that first number down. Then you're going to multiply 1 times -2 is -2. 3 and -2 give me 1. 1 times -2 is -2. 2 and -2 give me a 0 when I add. 0 times -2 is 0. -6 plus 0 is -6. Only that, -6 times -2 is a positive 12, which gives me a 0 remainder. So -2 is definitely a yes. Now, if you're lazy and you don't like synthetic division, graph it and see if that graph crosses at -2.
Those ones where you made us do like 100 synthetic divisions, they were when you factored it. I was like, oh my gosh, I did like 12 of them.
That's why I like to graph them, because if you don't know any of them zeros when you start out, you got to do all them combinations. And Lord, like you said, you might do it 12, 14 times, depending if that number's got a lot of factors.
Yeah.
All right, so I'll bring down the same numbers, and I'm going to check +2 now. Which I ain't going to lie, you could have chose these 4 numbers and done synthetic division with it. Because once you got one of the zeros out, that's the polynomial that's left. So you could have done them, but I always use usually the same ones and just run through it real quick. All right, so let's see if we get a 0 remainder. 3 and 2 is what? 5 times 2 is 10. 2 and 10 is 12. Times 2 is 24. Ooh, 24 minus 6 is 18. Times 2 is 36. And that don't look like a 0. So I'm getting like a 24 remainder. So that means no for the positive 2. Oh no, these are the ones y'all love, love, love. Find me a degree 4 polynomial with zeros of -4 multiplicity 3 and 0 multiplicity 1. So at least degree 4 is not as bad as a degree 5, degree 6, degree 7, I think I hit y'all with on the homework. But remember, multiplicity 3 means you got x equals -4 3 times. And then 0 with multiplicity 1s means 0 is an answer 1 time. When you write them 4 answers, you got to have 4 answers because it's a degree 4, okay? All right, then you're going to get all these numbers to the other side equal to 0. So the first 3, you're going to add 4s. And then the last one's already fixed. Now, you're going to put all these in parentheses and get ready to FOIL. Now, I'm going to tell you a trick on this. The single x is going to be in the front of mine. So I'm going to bring down my single x, and then I'll have x plus 4 3 times. And technically, it could all still be equal to 0. So now the fun part. First thing I'm going to do is FOIL the last 2. So are y'all good at FOILing? So if you're good at FOILing, can I just go to the answers instead of doing all the side work?
Yeah.
Okay, so I'm going to bring down that x plus 4. If you FOILed this out, and I'll show you how I do these. I know that's an x squared. I know I got to add the middle terms together, right? Well, in the middle is 4 times x is 4x. On the outside is x times 4, which is 4x. 4x plus 4x is going to give you 8x. And then you multiply the numbers at the end to get the last number, 16. So if you want to save time and instead of having all that junk on the side, just figure out the inners and the outers to get the middle. Okay? Now, I'm going to FOIL this together. Now I'll write that one out because there's a lot of stuff. So I'll bring the first x down, and then I'll put everything inside the parentheses. So let me tell you what's going to happen when you distribute this x. All 3 of them are going to gain an x. Right? X times x squared makes that an x to the 3rd. X times 8x.
It would be 8x squared.
8x
Oh,
squared.
yeah.
And then how about the x times 16? That'll give me my 16x. Now, when we distribute that 4, we can't change the variables at all because there's not a variable being distributed. So the 4 times x squared is a 4x squared. 4 times 8x is, what's that, a 32x. And then 4 times 16 will give it 64. So before I finish this, I got some stuff I can do in here, really. I'm going to bring down my x, bring down the x to the 3rd. But look, you got some x squareds that'll add together. So what I got, 8 and 4, so what's that, 12x squareds. Ooh, I got some x's I can add together. I got a 16x and a 32x. So that's going to give us a 48x. And then at the end, I'm going to bring down that plus 64. So my last step would be to take that last x and distribute it through those parentheses. Everybody's gaining an x. So that my final answer is an x to the fourth plus 12x to the third plus 48x squared plus 64x. All that's technically equal to 0, but y'all, all Math Lab wants is that polynomial. And we're happy because my highest exponent is a 4. So you had 2 to 4 on, that's one of them. Now I'm hoping this next one is what y'all would consider a freebie type question. But they don't require no math really, just your memory. So for my 12, suppose a degree 4, so suppose a degree 4 polynomial has zeros of I, well that's a negative I, so a negative I and 10 minus square root of 13. The other zeros are blank. So if I had a degree 4 polynomial, I know that's got 4 zeros in it. They're only giving me 2. So what's the 2 that I know should be there?
Positive I.
A positive I, because they come in conjugate pairs. And
And then is it 10 plus the square root of 13?
sounds good to me. You never change the number on to 10 because the radical part's where you get the plus and minus. So what was messing people up is the part where 840 had to write them as linear factors. When you write them as linear factors, you have to change the signs on everything. But when you're looking for zeros, just change the radical part and be done. So here's that other boiling one I was telling you about. And they're sort of sneaky on this one because they don't really tell you the degree. They just said find a degree of lowest degree. So for 13, I'm going to find a polynomial of lowest degree with zeros of square root of 3 and 5i. So my question would be, how many zeros do y'all think I have?
4.
4. Good job, because most of those will have conjugates, right? So I know I'm going to have x equals square root of 3, which means I automatically got a negative square root of 3. And then I got x equals 5i, which means I got x equals a negative 5i. So to save time, I'm going to get them all in parentheses with the signs changed, right? So this will be x minus square root of 3, x plus square root of 3, x minus 5i, and x plus 5i. Now, since y'all can foil pretty decent, I'm going to show y'all shortcuts on these. So I'm going to foil the first 2 together, but I'm also going to foil the last 2 together. So shortcuts, you're going to multiply the first 2 together on the conjugate pairs. So the x times x is the x squared. Now watch this. The positive times a negative is going to make this negative no matter what. whenever you FOIL radicals, you're always going to get a negative in the middle. So the question would be, what's the square root of 3 times square root of 3?
1.
So, well, square root of 3 times square root of 3.
Square root of 9.
Well, what's square root of 9?
3.
3. So y'all watch here. Conjugate pairs. First two get multiplied together. Second two get multiplied together. And remember, the radical times itself gives you what was under that radical. Now, I'm going to shortcut the second one because it's conjugate pairs. So x times x is x squared. Now let's think about this. You got a negative 5i times a positive 5i, right? So that would be a negative 25 I squared. But what do we say the I squared equals?
-1.
Negative 1. So that negative 25 I squared is going to become a positive 25. And it was good. Anytime you FOIL conjugate pairs of imaginaries, they're going to be positive. Radicals are always negative. Imaginaries are always positive. But he took me to the good part. Now I'm just going to FOIL those last things and be done. So I'm going to FOIL the last one. So let's see. I got an x squared times x squared is x to the 4th. X squared times 25 is 25x squared. Negative 3 times x squared is a negative 3x squared. Negative 3 times 25 is a negative 75. Oh, I got one more thing I can do to that. Yeah, they're right in the middle, right? So let's see, what's that going to give me? My x4? 22x squared. And then minus my 75. So that one just went along with that one, number 12, and just wanted y'all to realize that, hey, I got to have some more zeros in here. I don't know that I'd want to try to FOIL this 3 and that 5i. That'd be really ugly, okay? If you have to do that, you have it wrong. All right, so this is the one where I was talking about earlier. 1 0 is given. We're going to find the other zeros. So they're wanting me to figure out, I got an f of x is going to equal x to the 3rd plus 4x squared minus 5x minus 20. And the number we're checking is a negative 4 that they're giving me for my 0. So they'll usually write, I guess it's a semicolon, and then the number after it's the 0 they're giving you, okay? So we're going to start with a negative 4. Then let's see, I don't have any missing terms, so I got my x squared, my x cubed is a 1, 4 for my x squared, negative 5 for the x, negative 20. Now, since that's a degree 3, we know there's 3 zeros altogether. They're giving me 1, so I'm going to find the last 2. And remember, the last 2 zeros can always be found with the quadratic formula. Okay? We just got to get it down to 3 numbers under here. So first we'll bring that 1 down. 1 times negative 4 is a negative 4. 4 plus negative 4 is 0. 0 times negative 4 is 0. Negative 5 and 0 is negative 5. And then here we go. Negative 5 times negative 4 is 20, which gave me a 0. But we knew that better be a 0 or you got these numbers wrong somehow, okay? So you got 3 numbers. A is 1. B is 0. C is negative 5. Or you can write that as the x squared minus 5 equals 0 and solve it by square roots. Because that's what that's telling you, right? So on this one, you could add 5 if you wanted to solve it like this. X squared equals 5, and then square root it like we did earlier, right? So that x looks like it's gonna be a plus or minus. Can you do anything to that square root of 5? No, so that's just gonna be a square root of 5. So that gave me 2 zeros. They gave me the third one, so we're done. That's all 3 of them zeros, okay? Now this is doing the stuff that you were talking about long ago. List all possible rational zeros. So this is what you were doing to that one when you had to do synthetic division like 20 times or so. So they're giving me f of x is going to equal 18x to the 6 minus 18x third minus 6x squared plus 7x plus 5. And really, we don't even care what's in the middle. We just worried about that 18 in the front and that 5 at the end. So this would be my P and my Q. And remember, all the possible zeros are all the factors of P divided by all the factors of Q. So I got to figure out the factors of P and the factors of Q. So P is 5. So hell, that's just what, a 1 and a 5. 18 has factors of 1, 2, 3, 6, 9, and 18. Right, 1
Okay,
times
now
18.
where did you get those numbers from?
Oh, because 1 times 5 is 5, so that's all the factors of 5.
Oh, and
And then this is like 1 times 18, 2 times 9, 3 times 6. I just usually put them in order. So all the possible combinations are going to be, take this 1 and divide by all 6 of those. Then you're going to take the 5 and divide by all 6 of those. So that's going to give you 2 factors times 6. We're going to get 12 combinations of numbers. All of them could be plus or minus. Okay? So the first one could be a plus or minus 1 divided by 1, which is a 1. Then I'll take the plus or minus 1 divided by 2, plus or minus 1 divided by 3, plus or minus 1 divided by 6. So all I'm doing now is taking the 1 and dividing by all the numbers. What was next? 9, and then finally plus or minus 1 divided by 18. And then you do the same thing with the 5. So the 5 is the next figure on top. So 5 over 1 could be a 5. And then what?
5 over 2, 5 over 3, 5 over 6, 5 over 9, 5 over 18.
Okay. So without graphing it, this would have, there's 12 combinations, but each of them could be plus or minus. That's how possible. 24 zeros you could run through synthetic division until you found that first zero. So that's why I went to graphing them, because you don't want to do this 24 times. There you go, 16, find the domain. Well, let me try to keep y'all not too long, I don't think. So on top is x to the third minus x squared plus an x plus 2. On the bottom, x squared plus 11x plus 18. So the domain, we're only worried about the denominator. So I'm going to set my denominator to 0. At that point, you could quad that. But this is not bad to factor, because hell, everything's got to be positive on that one. So factors of 18 that equal 11.
9 and 2.
And there you go. So then we would solve both of those. So what would my final answers be out of that?
-9, -2.
-9, -2. So first, this one wanted this answer in set builder notation, and then they want me to do it in interval notation. Now here's the thing on the set builder. They want it in ascending order. Ascending order means from small to big, and then descending would be from big to small. So X is real, and X cannot equal. In descending order, the smallest of those two numbers would be -9. And then -2. And I'll tell you, the reason I think they do that is because in interval notation, the -9 has to be first and then -2. So that's the only reason I could figure them doing that. So it starts at -infinity until it hits that -9. Then we're going to union around that -9 until we hit that -2. Then we're going to union around that -2 till we hit positive infinity. Domain also. So the last part of this, I get y'all pretty quick, I think. So 17 is a domain again. F of X equals 1 over X squared plus 2X minus 35. So we know we're going to set that equal to 0. And then I'm going to factor, but y'all could hit that with the quad. I will say that this one will have unlike signs, because that last sign is negative. So what factor to 35 would give me a 2?
5 and 7.
And negative 5.
Because your 7's a bigger number, has to be positive like the middle. So solving these, you would get what, a -7 and a positive 5. So this one only wanted it in interval notation. So you start at -infinity. Let's see, I'm going to hit the -7 first. Union around that -7. Oh, then I'll hit what, the 5. Union around that 5 until I hit my positive infinity. Well, I might be able to get you right at the top of the hour. Let me try. This one don't take much. This one wants to know the horizontal asymptote. So there's 3 cases on this. So I got f of x equals x squared minus 5 over 5x to the 4th plus 7. So y'all, horizontal asymptotes look at the degree of the top versus the degree of the bottom. So which one's bigger?
The bottom one.
So when the bottom has a higher degree than the top, what's my horizontal asymptote?
0.
And we're done. If they're even, then it looks like the numbers in front. And if the top's bigger, there is no horizontal asymptote, okay?
So if it was even, it would be 1 divided by 5.
Mm-hmm.
Okay.
Or, yeah, say I had a 1 here and this was a 4 and that was a 4,
Yeah.
then it would be the 1/5.
Yeah.
Okay? So, hell, I don't remember what I had, but I think that was a 2. All right, solve. X minus 1 times x plus 2 is less than 0. So these ones I solved and set up my number line and tested me as 0. So if you solve the first one, x minus 1, you're going to get x equals a positive 1, right? If you solve the second one, you're going to get x is a -2. So let's set up our number line. Over here is going to be -2. Here's 1. I'm going to test 0, which is right in the middle. So let me ask you all this. If you put a 0 in for these two x's, is this going to be true or false? -1 times 2 would be a -2. Is -2 less than 0 true or false?
True.
True. So -2 is definitely less than 0 is true, which means I'm going to shade where that 0 is located. So I'm going to shade in between the -2 and the 1. So what MATLAB is looking for is what answer is this going to give me? Am I going to use parentheses or brackets?
Parentheses.
And then it's going to go from -2 to 1. So if it's true in the middle, you're going to have a pretty much a closed little interval. If it shades to the outside, then you're going to have those infinities involved, okay? Ooh, might make it, y'all. Number 20, here we go. Although number 20 ain't going to be factored. This has a x squared plus 23 less than 5x. Y'all, we know the first thing we're going to do definitely move that 5x over to the other side, because that's got to be a 0. Now, had that just been a number there, I might have played with it different if that x term wasn't there. But we got all the terms, so I got an x squared minus 5x plus 23, now less than 0. So we need to factor this. So I got an x and an x. Last one's positive, so both of these will be negative. All right, give me some factors of 23 that might add to get me a 5. There are none. So this will not factor. Now, if you did use quad, and the quad gives you answers that are radicals or imaginary, that pretty much means it don't factor. And if it does not factor, means that's a no solution. So y'all remember what MATLAB used for no solutions?
The 0 with the line.
The 0 with the line through it. That should be y'all's give me too, because I'm pretty sure every one of y'all's is going to be no solution on that one. All right, well, we knocked that out in an hour.
When would you use the brackets on number 19 instead of the parentheses?
I put that 1 equal.
Oh, yeah.
And that would mean -2 would actually make it equal to the 0 instead of less than the 0 or whatever. So that one little line makes a big difference on those. Alrighty, so that's open till Sunday night, and that test is already open for you. So knock out your study guide online if you want to. It's going to be just like what I did, and those are just like my tests. They just want to change the numbers up. But y'all will see, a lot of times when you're doing the study guide, you're going to see some of the same questions on my test, actually. So y'all will knock that out. Next week, we start knocking out the 9-3, 9-4 stuff. Okay? So just be careful. Blackboard shows my due dates a little different than my MATLAB because it wouldn't trickle my new dates over. So always go by MATLAB for those.
Okay.
Okay? And if we ain't covered it in class, it ain't going to be due on that MATLAB. Oh, y'all questions?
Isn't a trinomial the one with 3 terms? Okay. So, this was a long time ago, but the trinomial had a big number in it, factor, and instead of like factoring it, instead of using the quad formula, you used the calculator and factored it. But I used the quad formula and got like different answers in it, and I got it wrong. And I was wondering like why that's a thing. Like,
I'd have to. Only thing I could figure out if the quad giving you wrong answers is, was it putting them in decimal form or was it leaving them in the radical forms?
I'm not sure.
Because a lot of times, if they want what they call an exact answer, they just got to have the square root of 3 stuff in it. If you're putting them in decimal forms, then that's going to do what we call rounding them off or approximating them. Because those square roots of 3s are like never-ending decimals. So that could be one of the reasons. Other than that, I'd have to look at it, and I could probably tell you.
I mean, I got the answer right because I typed it in the calculator, but I was just wondering that. It was kind of
weird. That's the thing. On old quad formulas, might not have had the part where it kicked them back into the radicals like I put on mine.
Yeah.
But yeah, that'd be the only thing.
Bye.
All right, y'all have a good. And I'll send this out for y'all.